Okay, helper methods. So let's now go over some principle which I already mentioned in the earlier session today. So I'm going to start with some principle about what helper method really is, and then I will sketch some workflow for you to really follow. It's a very good software engineering practice for you to really start applying for all the subsequent labs. And then I'm not going to repeat the same example which I did earlier in the morning. I want to give you benefits for both. I'm going to go over another example. In the slides, you will see 3 examples there. So the first one, person collector, already did it in the morning. You can refer to the recording from the morning. And the second example, which I'm going to do with you, is something to do with the point, 2-dimensional point. The third one about some student deposit withdrawal, that one there I will leave as exercise for you. You can give a try on the Eclipse, and the solution can be found also on the slides, right? So you got all the 3 examples covered, right? Okay. But I'll try to really show you what's really going on in the Eclipse as well. I think that's important. Something we cannot do too much in the lecture. All right, helper method. So let's go over some bullet points, and then I'll switch to iPad and also the Eclipse. So after you completed and tested your program, let's say for lab number 1, you might be feeling confident that your code is correct. So correctness is always the first priority. You want to make sure your code passes all the test cases. But now, you want to be improving always. Now, what we really want to talk about is you want to avoid repetitions in your code. I'm not sure if you ever encountered this, maybe back in the first year. Let's say you're developing a Java class, maybe very large class. You find that you're writing the same block of code over and over in different methods. That's what we call repetitions, right? And there's an informal saying people like to refer to. If we can find many repetitions in your code, we say your code smells. So we want to get rid of that smell from your code. That's the goal. Okay? I'll show you an example, don't worry. So we want to eliminate, the one way to eliminate repetition is by factoring out the recurring code. I'll give you some analogy from math, which is very easy to understand. So what you really want to understand is about refactoring. So for example, if you see, let's say, x times y plus x times z. So here you can see we got some duplicates over here for x. Of course, mathematically, you wouldn't say that's a duplicate. I'm just trying to connect to the code. How can we somehow have only one occurrence for x? We'll do some factor. So what you will do is, I'm going to do some refactor, or just factor out x. So it's going to be x multiplied by y plus z. So you can see we only got one occurrence of x. That's pretty much what the helper method is going to try to do. If you see so many repetitions of the same block of code, we want to move that single block of code into a single helper method. Later on, whenever you want to refer to that block of code, just call the same helper method. That's the idea. We'll see. All right, let's go back to the slides. Over here. And the new helper method here. And then you can replace every occurrence of the repeated code by helper method call, which we'll see. And then the process is called refactoring, which I mentioned briefly yesterday in the class. Whenever you want to change the internal structure of your code, for example, by renaming your attributes, by renaming your class, or by defining some helper method, you're changing something internally to the structure of your code. We call refactoring. But it is very important, if you try to do refactoring of your code, correctness should never be compromised. So this is something I would like to visualize for you. And which we're going to also try to do a little bit more elaborate visualization when we talk about regression testing later in the lecture. But let's sketch. Let's imagine you got one version of your Java code. So I'll call that V1, standing for version 1. So that is your Java code. And what's good thing about it is that one there passes all the test cases of your JUnit test. Let's say JUnit test, and you pass everything. Check mark, like a green bar, right? So now I can say version number 1 is actually correct, which is good. If version 1 is not even correct, you don't even think about refactoring. Okay? Now, given that it's correct, you might find that your correct code over here smells because of repetition. So what should we do now? What we should do is we want to somehow moving from or evolving from version number 1 to version number 2, making sure all the repetitions are getting written off, and then they still pass the test cases. So they are both not spelling and also correct. That's what we want to achieve. Right? Let me finish the sketch, and then we'll do that on Eclipse. So what you want to do is evolving from evolve by helper methods. And then you're going to evolve into version number 2 of your code. And of course, realistically, you might have multiple versions of your code, of your evolution. May not be just 2. And this is just another version of Java code. And just remember, this one here has no repetition, no smell. And what's missing right now? You got to make sure this non-smelling code is also correct. If you got some code that's not smelling but incorrect, it's useless. Okay? So you want to make sure you also test to see that this part here also pass all the test cases. And that is correct. That's basically the workflow. So the example I'm going to go over with you is a simple one, but you can illustrate this workflow quite nicely. I'm going to start with some code over here and explain to you a little bit about what it is trying to do. It's quite easy. And then we'll develop one simple test case together. Just make sure that's correct. And then I want you guys to observe the code also to see whether there's any smell. If there is, we're going to see how we can fix it by defining a helper method. After that, we're going to rerun this JUnit test case to make sure we get a green bar. That'll be one complete run of the workflow. Okay, that's what we'll do. So let me now move on to the code itself over here. Let's take a look at this code first of all, right? So before we develop the JUnit test case for that, I want you guys to really stare at the code for 1 minute, all right? I want you to focus on convincing yourself there is a lot of repetition. Take a look. Have you guys seen the math class before back in the first year? Have you? Okay, good. Yep. Take a look, and then I want you to really see how bad this code is, even though it might be correct, to see how much repetition we have. And sometimes to really see the repetition, you don't really even have to understand exactly what the code is doing. Just by seeing the characters over here are basically so much repetition. You already spot there's something wrong structurally with the code. Okay, another 20 seconds, and then I'll highlight the problem to you. Okay, 10 more seconds, and then we'll go over. Alrighty. Yeah, just before I highlight anything, so let me just, for those of you who are not exactly understanding what's going on, so do you remember back in the math, if I got, let's say, 2 points over here, right? Let's say I got x, y. Let's say I got n and n. How do I calculate the difference between the two? Right? Well, I'm pretty sure you know the formula. Square root, for example, x minus n, see the difference between these two, and the square plus y minus n square, right? That's exactly what we're doing. But we're just doing that in Java. Okay? So now you can see that we got this part over here, square root, and the power, plus some other power, and then 2 and 2 over here. This part here actually got repeated every time, which is corresponding to, we're basically repeating the square root and also this one here, and also this and also this. That's what we are repeating. But as for the x, y, m, and n, there might be different values, but the pattern there is keep being repeated. That's not good. All right? So let me just highlight another one there. Here. You can see this one here. This part over here is also being repeated. Oh, so the minus is 1. This one here, square plus this minus this, right? This is being repeated also here, 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 and here. 1, 2, 3, 4, 5, 6. It repeated 6 times. Pretty bad smell for the code. So what we really want to do is we want to factor these out into a single helper method, which I'm going to show you. And then we want to replace every single line over here by a call to the helper method, but maybe with different input values. That's what we're going to do, right? And if you follow so far about a big picture, that's good. But for the exact details, you may have to redo the example yourself to really see. It's a very useful mechanism to really to learn. So let me show you on the Eclipse like what we can do. I'm going to make this available to you tonight. So that's a zip file you can download and import to your Eclipse. I'll just show you the procedure. So launch your Eclipse, and then gotta import the zip file. Okay. Just take some time to load. There we go. So whatever workspace you like, and then okay, get in there. Yep, there we go. So let's say import projects, and then under general, existing projects, and then make sure you choose select archive file and browse. And the one I'm going to import is this one here. Just start a code. And then you can say finish. All right, over here. And then under the source, under a package called helper methods, you got person and person collector. These are the example I did earlier in the morning. If you're interested in going through, you can refer to that part of the recording in the morning. Okay, it's already there. The one we're going to do is the point example, just one single class. And this student class here is for exercise. And you can find a solution in the slides. So now for the point, let's open that. That's the one we'd like to fix. And this one has in common to say this is the bad version with a code smell. If you see that, that's exactly what we just showed to you. You can see 1 repetition, and this is just another 2 repetitions, and etc. Right? What we saw in the iPad. So now how do we fix this? Before we fix that, let's make sure this particular bad version, even though it has smell, but it's actually correct. How do we show that it's correct? You're going to write some test case for that. In the interest of time, I'll just write one single test case for you, just one, so you can see the whole workflow. So now we can right-click on the JUnit test package and say new JUnit test case. And then make sure you choose JUnit 4. We can say test the point. Okay, over here. And let's say I just want to test one of the method here. Let's say this is the one. Just make it very simple. So there is one method here called get the distance from origin. Right? I want to know what's the distance from this current point to the origin. So for example, the one I'm going to do is a test case. Let me show to you. Let's say here, the point I'm going to create is 3, 4. Right? I want to know what's the distance to the origin. That one should be quite easy, right? 3, 4 should be 5. Right? That's like the very like a standard way of calculating. You just say square root 3 minus 0 square plus 4 minus 0 square, right? And then you can easily calculate it's 5. If you got trouble with the math, let me know, maybe offline. All right, so let's now translate this informal thinking into Java. So go back to Eclipse. So I'm going to do this. So you can say point, and you want to make sure because the point class is in a different package. So once you type the name, control space, and then Eclipse is going to suggest the point class from the helper methods package. So choose that. Right, so make sure it's imported. Yeah, double click. And you will see that here. That's an import statement Eclipse will put for you, right? And then I'm going to say P will be assigned to new point. And then I may say 3 and 4. No surprise, right? And then I want to make sure that method is correct. So as you learned from Lab 0 Part 1, what kind of assertion can we write? Assert equals, right? So assert equals. And one thing to note, very important, maybe I briefly mentioned that in the lab as well. If you go back to the point class over here, you can see the return type for this method here we're calling is double. Whenever you're trying to assert the return double value is equal to something, Eclipse requires you to really specify something called tolerance value, right? That's something I want to just mention that. It's also important to know. Because later on, if you have to write your own test cases for your labs or for the programming test, you have to know how to fix this. So if I say assert equals, right? So what's usually going to happen is there is going to be some actual value that's returned from the method. There will be some expected value. And here is some tolerance value. We call it epsilon. You may have seen that maybe back in your physics class or maybe some other engineering class. Anyway, it's called tolerance. What this can be thought about is you want to make sure the actual value is in a range between the expected plus or minus the epsilon. So that'll be plus epsilon or minus epsilon. That's really what it is trying to do. So you want to make sure you always specify some epsilon, right? One could be 0.001, something like that, right? Just small epsilon. All right, let's go back here. And then we go back to the test. So we can say here, we say P dot get distance from origin. And then I expect it to be 5. I allow some tolerance. If you don't have the tolerance, you can try. If you simply get rid of this part, it's going to complain from Eclipse. Okay? That's just one test case to make sure this method is correct for this particular input. Let's now try to run it. Right? Good, green bar, right? So we have some certain confidence about the correctness. Of course, it will be your exercise to really add more test cases to test the correctness of other methods as well. Right? But that's good enough for illustration. So what we have done, two things. If you recall this diagram here. Number one, we have identified this particular version number 1 smells. That's what we have done. Number 2, we have done this JUnit test case to show that this is correct. The next stage would be we want to create another version over here that's going to use a helper method to get rid of the smell. And then rerun this new version against the test. That's what we're going to do. Okay? Let's go back here. How do we create a helper method? Right? So what we want to do, let me give you some intuition. We agree that what's being really repeated is really this pink part. We always try to calculate the square root of some power 2 and also some power 2 and also the difference between these two numbers, right? We want to really put that pattern there in a helper method alone. And whatever value can be x, can be 2 and whatever, they can just be argument value or parameters for those for the helper method. Let's give it a try. Yeah. Of course, every time you want to create a helper method, the scenario can be a little bit different. So the examples I gave to you on the slide, just 4 examples. So when you get to the labs, it will take some experience and struggling to figure out. It takes some time. But sometimes if you, let's say you get to some repetition that you identify, you're not too sure how to get rid of them using helper method. You should really reach out for help, and we can help you figure out something. But anyway, let's do some simple stuff first. So we go back to the point class over here. So to avoid confusion, let me just copy that. You can do Control or Command C, Control or Command V, just to copy that and paste it. Let's say point improved. So that's the improved version. Right? You can see two versions over here. Let me close everything here. And then I'm just going to open the improved version. And I'm just going to change the comments very quickly. Improved version, which has a helper method. All right? And let's see what we can do. I'm going to give you the solution directly. And for helper method, usually we will declare a helper method or helper methods as private. Helper methods are only for use within your class. Any external user who want to use your class, they are usually not that interested in the helper method. That's usually the case. So a good practice would be just make the helper method private. To calculate the distance. Right? We can say private, and then we're going to have get distance from. All right? We want to calculate the distance between 2 points. It could be the current point, which will be this. I'm going to review the this keyword tomorrow in the class. And then another point. Other. So this is the only place where I'm going to repeat this code, only one. So just being a little bit lazy, I can go back to the pool version. I'm going to do some copy and paste quickly. Okay, let me just copy this one here. Okay, and then I can say this is the pattern. So distance will be square root of this dot x. So that will be the square root. Sorry, this will be the square. But you can use, rather than use power, you can also use multiply. That's fine too. Okay, and then this will be other. Sorry, did I miss anything here? So give me, yeah, sorry. Let me do it again. So math square root. Let me do it from scratch, otherwise I'll confuse you. Square root of, and over here, I'm actually going to do the formula. So this, so let's say math the power, and then raised to the power of 2 for 2 things. And we're going to add them. Math the power also to the power of 2, right? That's the overall structure. And then, so over here, this will be the this dot x minus other dot x. This dot y minus other dot y. And we're going to give a type over here. All right? Yeah, so I'm basically just translating the formula over here. That's what I'm doing. Okay? Kind of clear so far, just about what we're doing here, right? So we just defined the helper method, and then the next step will be we actually want to call the helper method. Let me just see what this error is. Not visible. Let me just see this. We may have to call the, okay, got it, because that's private. Other the get x. Other the get y. All right, fix it. So let's see how we can improve it. The first repetition over here. So this is where we want to calculate the distance from the current point to the origin, right? So instead of this repetition, we can make a helper method call. So we can say return this dot get distance from. So this is the helper method we got. And then we have to have the origin. So the origin will be new point, and then 0, 0. All right? So you might be wondering, why can we put a new keyword over here inside the argument? This is something called anonymous objects. Not too sure you have seen that in the first year. If you haven't, you can take it for now, and we're going to review the syntax of anonymous object also either tomorrow or Tuesday, right? But that's something you can do. All right? I'm going to do maybe 2 more, and then the rest I can leave to you as exercise, right? But the complete solution is on the slides. How about these 2? Let's just finish these 2. So now we want to say from the current point, we want to know what's the distance to another point, and what's the distance to another point, right? P1 and P2. So we're going to do it twice. So what we want to do over here is, so return this get distance from, well, here we can just put P1 because we want to get the distance to P1. And also we got another one here, this get distance from, and then P2. Let's see here, P1 and P2. And I think there's one more thing I will need to fix, because now we are talking about this particular class, so I may need to paste that, right? And then new point improved. So typically, if you want to introduce a helper method, you will just modify just the same file. You don't have to create a separate one. But now for demonstration purpose, I'm just showing to you 2 versions side by side, right? Right, that's basically what we're going to do. And then you can also try to replace these 3 repetitions as well. So now I'm going to give you some exercise for you to continue, right? And hopefully you get an idea. So exercise over here. Replace the following 3 repetitions by the helper method calls. And then create the same JUnit test to make sure that this improved version is correct. To complete the workflow. All right? All right, guys, is there anything that's conceptually not very clear to you, the workflow that we're doing here? So this helper method thing is very useful. So starting from your lab number 1, I would say don't worry too much about helper method when you do your first version to make things just work. But after things work, let's say everything passed already, you can now be more critical on your code structure. Try to see if you can identify any repetitions, like in the example. If you can, in that way, try to figure out a way to define helper method and get rid of the repetitions and make sure all test cases still really pass. So that's a very good way to self-improve your code. All right. If no question there, I'm going to stop here, and then you can feel free to continue with